Okay, so last thing to learn is your chapter 10 extension, right? So what this is on is the eccentricity of conic sections. Really what it's referring to is how round your conic section is. So like ellipses, right? If you think about an ellipse, we said it's a stretched circle. So some ellipses are definitely more oval than others, right? Whereas some that are closer to a circle, okay? So in an ellipse that looks more like a circle, the ratio of C to A is close to 0. One that's more of an ellipse or more of an oval, that ratio is close to 1, meaning that the center, or not the center, the foci is closer to the vertices, okay, versus closer to the center. So that ratio is called the eccentricity. And eccentricity is the letter E, okay? So if C is the distance from each focus to the center, and A is the distance from the vertex to the center, then the eccentricity, meaning how oval it is the ratio of C to A. Okay, so for an ellipse, that ratio is between 0 and 1. For a hyperbola, that ratio is greater than 1. For a parabola, it equals 1. And for a circle, it should be 0. Because there is no focus on a parabola or a circle. Okay? So we're just going to find the eccentricity of our conic sections. So how circular and how oval are they? All right. So a couple of examples. You have x minus 3 squared plus y squared equals 24. Okay, so first of all, looking at this, right, x squared plus y squared equals the radius squared. This is a circle. So the eccentricity of a circle is 0. Just decided what it was, could tell you what the eccentricity is. Okay, 4x squared plus 16y squared equals 16. What conic section is this? Okay, coefficients are the same sign but different numbers, so this is an ellipse. So it tells us that an ellipse is between 0 and 1. So we have to find it by taking C and dividing by A. Okay, so you have to find A, B, and C. So A, right, if you think about the standard form of an ellipse, it's x minus h squared plus y minus k squared equals 1, and then it's over A and B change, right? So the bigger one is A, smaller one is B. So we have to divide everything by 16 here. So we have to get it equal to 1. So we end up with our standard form as x squared over 4 plus y squared equals 1. So A squared is 4, so A is 2. B squared is 1, so B is 1. Okay? Then C squared is A squared minus B squared, which is 3. So C is the square root of 3. So our eccentricity is c over a. So square root of 3 over 2. You have to remember what a, b, and c are. Okay? All right, one more, and then that is all you have to learn for this year for Algebra 2. All right, so if I have an equation of an ellipse, or I want to write the equation of an ellipse that has a center at 3, 1, a vertex at 3, negative 2, and the eccentricity is 1 over 3. Okay, this tells us that this is c over a. So thinking about an ellipse in standard form, right? It's always x minus h squared plus y minus k squared equals 1. And then depending on which way it opens, tells you where a and b should go. So consider this graph, right? Center's at 3, 1. So 1, 2, 3. Here's our center and our vertex. So the center and the vertex are in a line. Okay, so that tells us the bigger number is going under the y term. Okay, so you already have your center. So it's x minus y minus. Okay, so the center is at 3, 1. So it's x minus 3 squared plus y minus 2 squared, or minus 1 squared. Then a is the distance from the center to the vertex. So how far is it from the center to the vertex? This is a. So that would be 3. Okay, so a is 3. So a squared is 9. All right. Then, and we also know this, that this would be a is 3, so c is 1. Okay? So we also know that for an ellipse, c squared equals a squared minus b squared. So 1 equals 9 minus b squared. So b squared equals 8. So the equation of our ellipse with eccentricity of 1/3 is x minus 3 squared over 8 plus y minus 1 squared over 9 equals 1. So we use what we know about ellipses to find a, b, and c and the center and the eccentricity, and we can write our equation from there.